Welcome to this awesome edition of Comet Algebra. This video is for Algebra 2, Chapter 7, Section 2, Rational Exponents. And that means exponents that are fractions, in case you're wondering. So first of all, I am not going to go over the table again of properties of exponents. That table is on page 293 of your book, where you have multiplying like bases, dividing like bases, a power to a power. You need to look at that and make sure you know that. It's so important for what we're building on later. So take a moment, look that over, and then we'll get started with these fractions. All right, we're going to look what happens when you have x to a fraction, fractional exponent. I rewrote it over here. The top number basically is the exponent. So this m is the exponent here. And this denominator is the root. So notice they're saying that x, the nth root of x is real, so we're not looking at imaginaries again, and that this top number m is an integer. It's not a fraction in and of itself. So we need to be able to convert from exponential form to radical, and then back again radical to exponential. So main part of this section is learning to convert back and forth. Start with an easy example. X to the 1/2 power would be the square root of x to the first power, so I'm not going to write the 1. X to the 1/3 power is the third root of x to the first power, which is just third root of x. X to the 2/3 power is the third root of x squared. So again, notice every time the denominator becomes the root, and that numerator is the exponent on your variable. So x to the 3/4 power would become the fourth root of x to the third. Okay, now let's go backwards. If I have negative 125 to the 1/3 power, that would become the third root of negative 125. Okay, I guess we're not going backwards yet, but I was thinking ahead. Also, I can't stop thinking about the Vikings game. They're playing Green Bay tonight in Lambeau. Kind of excited. So, all right, I'll get focused here. Sorry. 16 to the 1/4 power would become the fourth root of 16. And I don't know if you recognize it, but 16 is a perfect fourth, and this would be plus minus 2. We weren't asked to do that. I'm just going the extra mile for you. 4 to the 3/2 power, again, the root is the denominator, so it's square root. Square root of 4 to the 3rd. 4 to the 3rd, if you did that on your calc or you knew that, was 64. And so this becomes plus minus 8. All right, now let's look at those backwards problems I was talking about. When we have these in radical form and we are going to convert them into exponential, the first thing we want to do is take this number and write it in its prime factors. So we're going to be doing the 6th root here. So 27, I just happen to know this one, it's 3 to the 3rd. And then we just keep our variables separate the way they are. Now we know that this 6th root, this is going to become the denominator of the exponential fraction. So I'm not going to reduce them. I'm just going to be really obvious here, but you could reduce as you're going along when you're doing your assignment. So this becomes 3 to the 3/6 power times x to the 4/6 power times y to the 5/6 power times z to the 1/6. So all I did is took this root of 6 and I put it as the denominator in all of these exponents. And then, of course, we reduce fractions. So this becomes 3 to the 1/2, x to the 2/3, and I don't think I need to reduce these exponents. So that is this radical converted into exponential form. So let's look at another example. 64 in its prime factors is 2 to the 6th. And again, I'm just going to leave the letters with their exponents. So I have a to the 8th, b to the 6th, and then we're going to use this root, this fourth root, and that will become the denominator of all of these exponents. So I have 2 to the 6/4 times a to the 8/4 times b to the 6/4. And then simplifying our exponents, this becomes, well, I can't even read writing here. That was 6/4. Okay, so that must be 3/2 a squared b to the 3/2. So now that's written in exponential form. In these examples, we are given the problem in exponential form, and we're asked to convert it to radical form. Now, since the denominator is the root, you can't do these unless all the fractions have a common denominator. Oh yes, common denominator is back again. Yay. Since all these do have a common denominator of 5, we're in luck. This is going to be, in radical form, the 5th root of 2 to the 4th, a to the 3rd, b squared. So the only simplifying here is to do this 2 to the 4th, which is 16. So my answer is written as the 5th root of 16, a to the 3rd, b squared. In this second example, we do not have common denominators, so we need to change these. Common denominator between 5 and 2 is 10. So I rewrote my terms, getting ready for common denominator. 5 times 2 is 10, 2 times 2 is 4. 5 times 2 is 10, 4 times 2 is 8. And then these are both times 5 times 5. So now that I have common denominators, we know the root is going to be 10th root of 2 to the 4th times x to the 8th times y to the 5th. And so now we just need to do this 2 to the 4th, which we know is 2 to the 16th, or 2 to the 4th is 16 rather. So final answer, we write this as 16 x to the 8th, y to the 5th. What fun is this? All right, have a great time with this radical section.